Okay, so back to the cyclic servo setup. Now that I've got the servo balls on and the linkages on, there is a mechanical limit down here where the servo ball and linkage hit the servo case. So we're going to go down to the servo tab, enable servo override, servo tab, and enable the 3 cyclic servos. And we're looking at the right servo, which is servo number 3. And here's the servo saver. You'll see once we start getting down there, it hits a mechanical limit, and you see the smoke stopper do its job. So we need to, we're on the lower side of the servo output, so we need to change this limit. We're going to change its absolute value down. Still not there yet. It's the wrong way. Okay, so we've gotten far enough down. We're past the original 50 degrees where it would bind. Now we'll start bringing it back up until we start seeing it bind again. Okay, so around 400. The bind's gone, the linkage isn't hitting. I can move it freely. We'll save that. And the other aileron cyclic servo does the same thing. All right, so we can working with servo number 2. You can assume it'll be close to what the other one is, but it's working in the other direction on the output. It's on the upper side because the servo is reversed. So we'll be looking at the max number here. And we'll take it down to 400 just like the other side. And we don't have any binding. This linkage moves, and we can save that. So now we're going to go to the mixer tab, enable mixer override onto the mixer tab, and we're going to be adjusting the scaling on the mixer to get the output of the helicopter to match what the flight controller is asking it to do. I've got the landing gear off this helicopter to get it to sit level on the desk because the 470 landing gear has a rake to it. I also calibrated the accelerometer while it was sitting level on the desk. All right, so enable roll, pitch, and collective, and move the roll over to 9 degrees. And we're getting almost 11 degrees on the output of the helicopter. So we will lower the scaling. Now we're asking it for 9 degrees, and it's giving us pretty close to 9 degrees. Go up to 12 degrees, which is it's set as the maximum on everything. Roll, pitch, and collective. Getting a little bit less than 12 degrees, and I would rather it be more accurate at higher blade angles. It may not be, perfectly linear. Okay. There, we're asking for 12 degrees on the roll axis. Let's go ahead and line up the blades with the swash blade a little better. We're asking it for 12 degrees, and it's giving us 12 degrees. Back to 0. Speed control is just going to keep resetting. Sorry about the beeps. And we go to 6 degrees. That's a little more than 6, but again, I'd rather have it be accurate at higher blade angle. May not be linear through the full range of motion. Alright, there's the roll axis. Now we're going to change pitch axis. The elevator axis, not the collective pitch, but the pitch/elevator axis. So we're going to ask it for 9 degrees. And it is also overshooting by quite a bit. Okay, so that's close to 9 degrees. Let's go to the maximum of 12. A little bit shy again. Alright, it's pretty close to 12 degrees. And it's not the same as roll, which I would have thought they'd have been the same, but I guess not. Back to 0 degrees. Back to 0 degrees. There's 12 degrees. That's the elevator axis. Now, collective pitch. We'll go to 9 degrees. We're getting a lot more than that, so we'll have to bring the scaling down. There's close to 9. We'll bring it up to the maximum of 12. I'm not going straight to 12 because I think it would might be past the mechanical limits. Like the swash ball on the T-Rex 470, it starts to bind at around 13 degrees. So we're getting 12.5. All right, so 720, we ask it for 12 and it gives us 12 on the output of the helicopter. Let's go ahead and save that. Okay, while I was editing the video, I noticed I was half a degree off at 0 degrees when I rotated it to work on the pitch side. So I'm back in here and I'm going to try and tweak on it a little bit. Move it to 12 degrees. Sure enough, it's off. Okay. There's the elevator. Now the collective. It's also off. Okay, that's better. Half a degree is a little bit more than I was comfortable with, but it's not going to be perfect. The servo outputs aren't linear, like your cyclic output at, say, positive 5 degrees. We'll go ahead and zero it out so we can see the difference. But at positive 5 degrees cyclic, when you move the elevator, you're not getting 12 degrees pitch anymore. And that's because, the servos move in an arc. But try to get it close to minimize that. Back to 0 degrees collective. And now we're getting 12 degrees on the cyclic. Anyhow, I like that better than leaving the half a degree error in there. And now we'll work on the tail. Back to the servo menu. I already set the sub trim on the tail servo while I had it out of the helicopter, and I did not video that. So negative 31 on the sub trim for the servo. Put the servo arm at 90 degrees to the servo case. We enable that. I've already been through this, and I didn't record sound on that video. But what I ran into when I first set it up was I had a mechanical problem where the tail was not centered. The servo was at 90, but the tail pitch slider was offset to one side, so that I was having to limit one side and not the other. And rather than leave that limit set on one side, I lengthened the linkage on the tail pitch slider between the servo and the tail pitch slider. This linkage here, I screwed it out a little bit to center the slider within its range of motion. So now I can go full range of motion, which is pretty extreme on the tail, and I don't get any mechanical binding. I did not have to change the min or max, and when I go into the mixer tab, I get full range of motion without having to limit the scaling at all. And I prefer that over any sort of scaling on the rudder servo. You get that by moving the ball in on the servo. So I'm going to go ahead, try and spin it around. I don't think it will work very well, but okay, nothing. Not too bad. You can see the servo ball is pretty far in on the arm. The 470 manual tells you to do that, and that gives you the full range of motion of the servo without any binding. And, if you had the servo ball further out on the arm, you would have to limit the scaling or the output of the servo to keep from running into the mechanical binding, and you would be wasting some of the servo's available resolution. And on the direction of the tail servo. When you move it to the right, you want it to rotate to the right as if you had given a right rudder command on your transmitter. The other way to look at that is when you turn off the override and rotate the helicopter, you can see the gyro counteracts what you're doing. When you move it to the left, it gives an input to the right to counter what you're doing. And you'll look for the same thing with the cyclic. When you lean the helicopter to one side, you want the swash plate to counter that. It'll look like the swash plate will be trying to keep itself level. And in my last video, I used the mixer tab to see what direction the servos were going, and that was unnecessary. What you should do, according to the wiki, and I went back and reread it and noticed that what I'd done was a lot more complicated than what they suggested, is you move the slider to the right and you want the servo to go up. You want all the servos to move the same direction when you move the slider up. When you move the slider to the right or up, all these servos move up. When I move them back down, they go back down. So the configurator and the flight controller know which corner each servo is on and what direction they're moving. That's enough for it to move all the mixes in the right direction. It's a lot easier than bouncing back and forth between the mixer tab, which was what I had originally done. I ended up in the same place. I reversed servos 1 and 2, so now they move up when I move the slider to the right, just like the elevator servo, which was moving the right direction to start with. Or, excuse me, it was the right servo that was moving the right direction to start with. And I had to reverse the elevator and the left servo. They all move up when you move the bar to the right, when you move the configurator to the right. It's a lot easier than what I did. But that servo set up, everything's pretty close to ready to fly. Just a little bit more mechanical setup, but the nuts on the servo arms, a little Loctite here and there, the landing gear back on, and it will be close to ready to fly. I saved everything that I did there. And saved my limits there. So yeah, everything should be pretty close to ready to fly. Still have some motor setup to do. Need to program the speed control to output the 7.4 volts. Right now it's only putting out 6 volts, what the speed control defaults to. And not too much more. I think she'll be ready to fly.